So what we have here is a bullet of mass m. It's fired with its speed u onto a fixed block of wood and is brought to rest in a distance s. Find the resistance to motion, assuming it to be constant. Okay, so if we stop the first question seems to stop here. We'll just transfer this over here, and we can resist motion. All right. Now we're going to start off is we're going to draw the block like so. Okay, and we're going to represent the bullet with this little here. Okay, the ellipse hits the edge of the bullet. Okay, and what we're assuming is it's at speed u when that happens. Okay, so that's u here. Okay, it's brought to rest, so it enters the bullet and undergoes a massive deceleration, and its distance s within the block is rest. It's going to be the e value is going to be 0. Okay, so what we can do here is we can sort of have a look at the UVST here, UVAST. So U starts off with U, V is 0, A we don't know. We know that it takes a distance S to bring it to rest, and T we don't know anything about. Right? Now what we do know is force equals mass times acceleration. And in this case, there's only going to be one force in question. The only force in question is going to be the resistance of the material, is the resistance of the wood on the bullet. So the resistance is a force that slows it down. What we're going to try is we're going to use v squared equals u squared plus 2as to begin. And what we're going to get is 0 equals u squared plus 2as. It has to be a deceleration, remember. Then we bring everything around here. And what we say is that we can get the deceleration first. So I'm going to bring over the u squared. The u squared equals 2as. Means that your deceleration a is going to be minus u squared, a negative value, over 2s. Okay, just park that off there. Nothing more else we can do. Let's rub this out. And this is scenario 1 wrapped up. Now find the resistance to the motion. Haven't quite done everything yet. Find the resistance of the motion. Resistance will be force equals ma. Means the resistance will be ma because it's a force. So it's going to be r equals m multiplied, so it's going to be minus mu squared over 2s. Okay. Next part after that. Another bullet also of mass m is then fired with speed 3u into another fixed block of thickness 5s. Offers the same resistance as the first block. Find the speed with which the bullet emerges and the time it takes to pass through the block. Ouch. So in this case, the initial speed is so fast. So once again, we have our block of wood, and because it has a thickness of 5s, this means that you're going to go through a distance of 5s of decelerating. The bullet, which I'll represent with the ellipse, again is here at the start. Now, because it's going 3 times as fast, 3u this time, it actually doesn't slow down. It actually passes right the way through it and continues out the other side. So we have to do UVAS once again to figure out how much did we actually slow it down by. What we have is UVAST. U is 3u. V value we don't know. We actually don't know the V value. A value we know because it's the same consistency as the last one. So it's the same deceleration as the last block provided. So that's minus u squared over 2s, which is handy to know. The distance is 5s. When you're doing 5s and s's together, it's really advisable to keep the numbers much bigger than the letters. So 5s. So it's really obvious which one's the 5 and which one's the s. Okay. And the time we will be looking for that, but I might not get that initially. So I'm going to go for, let's go for phi squared equals u squared plus 2as. So phi squared is phi squared, that's what we're looking for at the end of the day. U squared in this case is going to be 3u 2b squared plus 2 times s, so 2 times minus u squared over 2s, and then multiply by s. Now the s's will cancel, 2's will cancel, and what we get is 3u squared minus u squared, so phi squared equals 2u squared. Square root both sides, phi is going to equal the square root of 2u squared, which is root 2. Okay. Find the speed at which takes the bullet emerges, done, and the time it takes to pass through the bullet. Well, the time it takes, we might try v equals u plus at, and in this case we can say that v is root 2u. U is 3u. A is, I suppose, minus u squared. I'll get rid of that s in a different manner. Sorry lads, actually made a mistake up here. Sorry guys, I didn't go too long. I actually made a mistake up here, bit of ring rust. So it's plus 2 over, what's that, 2s. 3u 2b squared is actually 9u squared, so that's my fault. And then over here they cancel, so it's going to be minus, so the 2's cancel, it's going to be minus u squared. Actually, another thing I did wrong was, believe it or not, it's not s, it's actually 5s, because it travels a distance of 5s. It doesn't travel s, it travels 5s. So it's going to be 9u squared, take away 5u squared, because remember the distance traveled is 5s, not s. We're going to get 4u squared, and this is a bit better. Then square root both sides, v equals square root both sides, and get phi equals 2u. Right, so that's a nicer answer for this question. Okay, next thing we're going to do is we're going to use phi equals u plus at, where phi equals 2u, u equals 3u, because that's what it starts off with. Acceleration is minus u squared over 2s. And we're going to get minus 1u equals minus tu squared over 2s. We're going to get rid of the negatives on both sides. And we're going to get that u cancels with that u. So, and the negatives cancel as well. And what we're going to be left with is t equals 2s over u. I'm taking there. Right? Sorry about the errors in that. It was a bit messy, but we got there in the end. 13 will be a bit easier, right? So first thing I notice is I don't deal in grams, I deal in kilograms. So what's 1 kilogram equals 1,000 grams? Divide that by 100. So 1 over 100 kilograms equals 10 grams. There we go. Now, a particle of mass 10 grams falls from rest from a height 2.5 meters onto a soft material into which it sinks 0.35 meters. Neglecting air resistance, calculate the constant resistance of the material. Okay, so imagine your particle up here, and then it hits the surface, which is the black line, and then it stops a certain distance down. Okay, so what we need to do first is we need to find how fast it hits the ground at. So what we're going to use there is we're going to use u vast, so u equals 0 because it falls from rest. V equals, we don't know. A equals gravity, which is 9.8. S equals 2.5 meters because that's what it is. And then we have T. No. I'm going to use v squared equals u squared plus 2as, and I can find out the velocity at which it hits the ground. So we have v squared equals 0 squared 2 times 9.8 times 2.5. 5 times 9.8, 49. So v squared equals 49, and phi equals 7 meters per second. Okay, so we have the phi value. Starts off here at 7, and then 0.35 meters later. Now, the difference between this question and previous questions is there's actually two opposing forces here on the particle. Okay, so if you imagine this sphere as the particle, say is that weight acts downwards while the constant resistance acts upwards. So there's opposing forces here, and we need to get the net force. Weight equals mass times gravity. Weight is going to be mass, which is 1 in 100 kilograms, multiplied by 9.8, is going to be, you can write it as a fraction, 49 over 5,000, or you can do, oh sorry, over 100, my fault. 49 over 500. Or if you really wanted, say 98 over, or one you feel comfortable with. Or you can do it as 0.098. Handy number as well. So the weight acts on 0.098 newtons going downwards. So this is 0.098 newtons going downwards. The upward force has to be greater than that, because the upward force outpowers the downward force, because the upward force causes it to go to rest. So this resistance force is bigger than the weight acting downwards. That has to happen, right? What we can evaluate next, we can start off with u vast again, except this time it hits the ground. It starts off at 7, because 7 is where it hits the ground here, and it's starting to encounter resistance R as it burrows through the ground. So it only goes 0.35 meters, and we know it stops. We don't know the acceleration anymore, because the acceleration is now a mixture of the resistance and the weight. So it's deceleration, in fact. So we're going to get v squared equals u squared plus 2as. And what we're going to get is 0 equals 7 squared 2 times 0.35 times s. So we're going to get bring the 7 squared over here, so it's going to be minus 49 equals 7 times s, and then s, oh sorry, I'm getting a and s mixed up here. It's 2a times 0.35, because s 0.35, so it's 0.7 times a, my fault, and then 49 divided by 0.7. So your acceleration is minus 70 meters per second. All right. So the net force is basically your weight minus your resistance. What goes down minus what goes up, and this results in this results in negative acceleration, because R is bigger than W. That's guaranteed. We know R has to be bigger than W in a net deceleration. Now, net force MA. MA in this case is your 1 out of 100 kilograms, multiplied by your deceleration, which is minus 70. That equals your weight, 0.098 newtons, minus your R value. This means our R value minus R is going to be, what's that, minus 0.7, minus 0.7, minus 0.9098. Resistance is going to be 0.798 newtons when you add both of them together. Both sides will be negative, multiply both sides by negative, and you get a positive shown. Next one. A ball of mass m falls vertically from rest at a height 4h onto marshy ground whose resistance is of magnitude 8 mg newtons. In terms of h, the depth to which it will penetrate the marsh. Alright, no bother. Well, I need the speed at which it hits the marsh. So here, and it falls and hits the marsh here. Then it sinks into the marsh and stops around here. Right? So we're going to start with v squared equals u squared plus 2as. V is what I'm looking for. U is rest, so we're going to start off with 0. A is gravity, which is 9.8. In fact, I'll keep it in terms of G because I noticed that the resistance is in terms of G, so it'll be 8G and it's 4H here. So we're going to get V squared equals 4GH, or sorry, 8GH. And then V equals square root of 8G. Alright, so I don't really need most of that info. All I need is these two parts here. The two of them can sort of stand side by side. So that's what we know here. That V, this is where V is, right? Then we go down and we get a velocity of 0. Now there's two things at play here. There's force due to gravity. There's the weight of gravity acting downwards, and then there's the resistance acting upwards. Now, we know that gravity is mg. We know that the resistance is 8 mg. This results in a net force of 7 mg going upwards. The net force of 7 mg decelerating the object. Okay? So force ma, the net force is 7 mg. This results the same as ma. This should result in a deceleration of 7g. 7g is the deceleration. So we do UVAS one more time, where we do U, V, A, T. In this case, we know that the V value starting off, what velocity does it hit the ground at? Well, it hits the ground at root h. Oh, sorry, that's the U value, not the V value. U value. Comes to rest. How far are we going to the march? Well, this is when V equals 0. Its deceleration is 7g. S we don't know, T we don't know. We're looking for S, how far it will decelerate in. So in this case, I'm just going to use v squared equals to u squared plus 2as. And in this case, what we're going to see is v squared is 0. Square out u squared and you get agh. 2as is going to be minus, it's going to be 2 times minus 7g times s, so it's going to be minus 14gs. Then cancel the g's, so you're going to get 14gs equals 8h. S equals 8 over 14h, 4 over 7h. So our answer to the first question is 4 over 7h. Okay, that's no. Next question is, would a mass of 4m drop from the same height h? Sorry, would a ball of mass 4m drop from height h penetrate the same distance? Okay, so we're actually going to have to go back to the very beginning of the question. So rub all this out for a minute, and we're going to go again. So in this case, it's a mass of 4m, which means it's 4 mg going downwards. The deceleration, it's 8 mg resistance, 4 mg weight. It's going to be 4 mg deceleration acting upwards. The other issue is he also dropped it at a different height. He didn't drop it at a height of 4h, he's actually dropping it only at a height h. So we're going to do phi squared equals u squared plus 2as again. And phi squared is what we're after. U squared is 0 squared. Now it's going to be 2 times g times h, because it's not 4h, it's just h. So what we get here is phi squared equals 2gh, or phi equals h. That's the new v value. Next thing, he enters the march, and it enters the march and it decelerates down to 0. And what we're looking at here is, how does it do this? Okay, well, as we said earlier, it has an 8 mg resistance, and weight is mass times gravity, but your mass is 4m this time, so it's a mass of 4 mg going downwards. 8 mg take away 4 mg is a net result of 4 mg going upwards. So we now have we do our force equals ma. Your net force is 4 mg going upwards. This means that your deceleration is 4g. 4g acting to slow it down. So we do UVAST one more time. So UVAST, UVAST. Right. U is root 2gh. E is 0. A is minus 4g. S is what we're looking for, and T we don't know. So once again, we're going to do phi squared equals u squared plus 2as. Phi squared is 0. U squared is 2gh. S acceleration is negative, remember, so it's going to be minus hes. Hes equals 2gh. The g's cancel, and s is going to be 2 over 8h, h over 4. So they're different amounts. This one doesn't penetrate as much as it turns out. Because when you're doing any questions, just verify with the book as well. That's what I always do anyway. So these guys got an answer of h. I got h over 4, which is interesting. Minus 2g. Alright, give me a look at it. Okay. Oh, I had the deceleration as, no, my deceleration is minus 4gs. Well, their deceleration is minus gs. Oh, I see what I did wrong. Verify. So remember I said force equals ma. Well, it's not ma, it's 4ma, which is the issue. So then 4g equals 4a, a equals g. So the deceleration was not actually g, it was minus g. So it just shows you a bit of rust can kick in and you can just make little mistakes where you shouldn't. So this here should be minus 2gs. That will make that 2gs, 2gh. 2g's cancel, s will equal h in this case. So just be aware of the little things when you're not using m, you're now using 4m. It can happen very easily. So just make sure you fix up those mistakes as they happen.